Alright, so we're going to talk about rotation of axes. So up until this point, we've not discussed a form where we can have a product of x and y in the equation of the conic sections. So we use rotation to actually deal with that. Okay, and okay, so we talked about translation previously, which involves studying a conic section away from the origin, where you come up with the new coordinates about the new point. And then we came up with a new form where we said, for example, when you're looking at a parabola, instead of looking at an equation in not necessarily a parabola. So for example, if you're looking at an ellipse with that form of an equation, what you can actually do is in the new form we said it can be expressed as x minus h squared over a squared plus, and then y minus k squared over b squared. I showed you how to move from that form to this form, and all that went well. Okay, now to, today I don't know when you're watching this, but in this video basically we're going to talk about rotation of axes. So basically, how do we rotate? So by that, what we're trying to talk about is we are rotating the axes. So if you've got x and y, why do I like putting x on top? So y and the x, this is the original x or y plane. Okay, so what happens if you rotate it counterclockwise or clockwise, maybe by a certain magnitude of an angle this way? So if you rotate the x y plane, it's going to be like this, and then you do the same and rotate the y by the same magnitude. Okay, then you have it there. Okay, so this becomes your new y and then your new x there. And so let's picture you had um, maybe a parabola along the using the original coordinates. Maybe it was like this. So when you rotate it by that same magnitude, the fact that it's along the y-axis like this, if you rotate it, it's equal going to be the same, but it would be in the new coordinate system. Okay, so that's basically what rotation is. Okay, so I've shown you now the the practical. Let's get to the theory now, where we perform calculations and see what we can do. So the equations that we're going to use, let me put for you the equations we're going to be using to create a relationship between the x and the x prime and the y prime as well. So our x is going to be given as x prime cosine of alpha minus y prime sine of alpha. The only secret to remembering formulas, of course I do give you some hints where it's necessary, but the biggest secret is practice. There's no way you're going to remember all these formulas and the conic sections by just watching the videos, going for lectures, and yet you don't ever solve questions. So we've introduced now a case where we are going to add a lot of PDF questions on the site that will allow you to practice, and then we're also going to add some PDF solutions for references to just ensure that you do a lot of practice. So these are the two equations that are going to be very cardinal. Okay, and of course there is going to be a form where you make x prime the subject and whatnot, but we're going to work more with these ones. Okay, so let me just give you the other formulas as well. X prime is equal to x cosine of alpha plus y sine of alpha, and then your y prime is equal to negative x sine of alpha plus y cosine of alpha. So these are the equations we're going to work with. Okay, now straight away we'll look at an example which is going to have, I said rotation helps us do away with the term x, y, right? Okay, and so there we are. So we have been given 2xy is equal to 9. So we are told the x and the y axes are rotated through an angle of pi over 4. Radian is about the origin. Find an equation for the hyperbola in the new coordinates. Okay, so we have to find the equation of the hyperbola in the new coordinates after rotating it by that magnitude. Okay, so let's just do that. So the very first step that we need to work with is we need to find the angle. Remember the formulas that I gave you? Our x is equal to x prime cosine of alpha minus y prime sine of alpha. And then for the other one as well, starts with x prime, except it's like the opposite. So everything else is the opposite. I think that's what can help you. Okay, so you start with, if you can remember one, you can easily remember the other one. X prime cosine alpha minus y prime sine alpha. This will be maintained, and then this will be the opposite, including the signs will be the opposite. So let's do a simple exercise and try to remember the formula. Don't look at what you've written. Okay, so a simple exercise was x is equal to x prime. It was cosine first of all alpha. Is it cosine? Yeah. Cosine alpha minus y prime sine of what? Alpha. Now for the second one, y, x prime is maintained, then everything will be the opposite. So we are going to have sine of alpha. The sine will also be opposite, and then y prime will be maintained, but it will be cosine alpha. Okay, so you can do that simple exercise every time that you're solving this question to just help you recall. Okay, so we've been given the angle alpha. We're told alpha is equal to pi over 4. So we don't have to find the angle like I said. We just have to go and substitute into the equations that we have. So for our x is going to be equal to our x prime cosine pi over 4 minus y prime sine pi over 4. Okay, so that's the first step there. And then of course, as you might guess, we have to now do the same for y. X prime sine of pi over 4 and then minus y prime cosine of pi over 4. So I can see there's repetition here. There's no need of us to complicate things. We can just go on and just simplify. So if you don't understand radians, don't worry, I'll still assist you. So cosine pi over 4, put 180. If you want to think of it in radians, where there's pi, put your 180 and then over 4. So if you divide 4 into the 180, how many times is that? So that's 45. So in short, we're talking about angle cos 45, which is coming from a special triangle and whatnot. So what is cosine of 45? That's as simple as 1 over root of 2. Okay, 1 over root of 2. So in this special triangle of ours, we understand that we've got 45 or pi over 4. Okay, and then we've got a 90 on top. We've got 1 there, and then the hypotenuse is root of 2. So if you use SOHCAHTOA for sine opposite of hypotenuse, you're going to get 1 over root of 2, and for cosine as well, you get the same. So this is a case where we know that sine and cosine 45 are the same. So we can just substitute that. So we are going to have x prime cosine pi over 4, I've said is 1 over root of 2. So when you multiply x prime with 1 over root of 2, it's the same as just over root of 2, and then minus y prime as well over root of 2. since we're multiplying by 1 over root of 2. Okay, which you can actually just now combine the denominator since it's the same, so you can just say over root of 2. Do the same for the other one. So you're going to have, so here the sign is supposed to be positive, I beg your pardon. Okay, so we're going to have x prime over root of 2 as well, plus y prime over root of 2. We can also do the same, come up with a common denominator, which is just the same. Okay, so now we've simplified, we've expressed our x in terms of x prime and the y prime. Okay, that's the first step that we needed to make. Okay, now after you've done that, you just have to go back to the equation that we have, the equation that we were given, and it's very simple at this point. We just substitute now. Where there's x, you put what we found. So we're going to have x prime minus y prime over root of 2, and then for y we have x prime plus y prime over root of 2 as well. Okay, then this is all equal to our 9. Okay, can we simplify this now? Sorry. Now that we've substituted, we can actually go on and simplify. Okay, so don't forget about 2, which is outside. So let's just multiply what is inside the brackets. X prime multiplied by x prime, that would be x prime squared, right? So x prime squared, and then minus times that. So this is actually a difference of 2 squares, so it's just going to be x squared and y prime squared. So the middle part is going to subtract. If you want, you can go on and show it. I don't have to show that to you. I believe you know what the difference of 2 squares is. If you want to try out x prime multiplied by y prime, okay, you'll see that you're going to get what I've written there. And then on the bottom, root of 2 multiplied by root of 2 was asides. Whenever I'm multiplying the square root by the square root, it will disappear, so we remain with a 2. And then this is equal to a 9. The 2 would divide, and then you remain with x prime squared minus y prime squared being equal to a 9. At this point now, to express it in the form of a hyperbola, you want to have a 1 on the right. So divide by 9, divide by 9, divided by 9. So you have x prime squared over a 9 minus y prime squared over a 9 is equal to a 1. Okay, so you have it now in that form. Okay, so you've now found the equation for the hyperbola in the form that we wanted in the new coordinates. Okay, and there we are. Can we give you a rough sketch of it? I already showed you what we mean by rotation. So if you've got a protractor, you can actually measure the angle 45. So 45 is the half of that. Okay, so do the same as well. I don't think my angles are accurate. So this one is going to be, this is our y, that is our x. So this is going to be now our new x and our new y. So the question is, if you look at what we have in this kind of an equation, is it along the x or it's along the y? So you look at what you've started with. So we started with x, okay, and then subtracting with y, so it's going to be along the x-axis. How does the hyperbola come out? So these are parabolas that are kind of like opposite, facing in opposite directions. So since it's going to be along the x coordinate, remember this angle should be, we've rotated it by pi over 445. So it's going to be something like this. Let me draw it using a black. Okay. Okay. And they did in this side as well. Okay, so that's our hyperbola rough sketch. We haven't found the foci, we haven't indicated the vertices values as well. Okay, so I hope that has given you an idea of what we've actually done. Now, a simple exercise for you. I love it when people take part. Okay, so it's been a lot of videos since we talked about the equations of a hyperbola. So now I have given you an equation now. Okay, this is the equation that we have. So I want you now to, in the same new coordinates that we have, I want you to find the foci, the vertices, and the center for this hyperbola. Okay, so feel free to pause the video and just try to do that as a simple exercise. Okay, now I want to look at another form of a question. I want to look at another form of the question about rotation. This is now a case where they have not given us an angle, but again we are still seeing that we still need to eliminate the x and the y, and also be able to identify the conic section, because if you look at this equation, we can't identify the conic section that we are talking about, so we have to find the angle theta and then also identify the conic section. So there's a new concept now, finding the angle theta, which we haven't talked about up until this timeline in the video. So let's just do that. So the way we find the angle theta is in two ways. You can either be using the cosine 2 alpha, this is a double angle, a minus c over b, or you can actually use tan 2 alpha is equal to b over a minus c. So now some of you are already asking the question, what do the letters or what do the constants a, b, and c represent? So the assumption is every single time we're going to be starting with x squared, right? So our a represents a coefficient of x squared, in this case a 2, and then our b represents the part that is attached to the product, and then our c represents the coefficient of the y squared term. Okay, so just to give you a bit of some more detail, if I was to write a prime x prime squared plus, or even I'm just writing the term of xy or not. So let's say how I have a x squared plus bxy plus cy squared, and then d would be the part attached to the x and e would be the part attached to the y, and then the constant would be f. So the ones that we are interested in are the first three: a, the coefficient of x squared; b, the coefficient of the product, which is the term that we're eliminating; and then c is the coefficient of y squared. Okay, so what do we do now? So let's now undo the question that is at hand. So we first of all need to find the angle based on the values that we have. So I've said a is the coefficient of x squared, and then b is the coefficient of the product, and then c is the coefficient of y squared. Okay, so let's use the tan. So tan to alpha is equal to, okay, so what did we say? We said it's b and then a minus c, right? So our b is what? Root of 3. Our a is 2, our c is a 1, so we'll just find the 1, so end up with root of 3. Okay, so to find the angle alpha, what do we do? So we can find the tan inverse of root of 3, tan inverse of root of 3. So assuming calculators are not allowed, if you assume calculators are not allowed, and then you look at just look at the special triangle, 30-60 triangle, that's why we find the root of 3. Okay, so you know from that triangle we've got the 30 and the 60. The 30, which if you convert to the radians, gives you what? Pi over 6. Pi over 6. And then you also have pi over 3, which is your 60. Okay. So sine 30, which is pi over 6, is, so Katoa tells us, so I don't want to teach you trigonometry, but you can actually request access to the math course. We enroll you for free, and then you can actually go through the special triangles and whatnot. So I believe you understand that's going to be, the opposite is going to be 1, the hypotenuse is going to be a 2, the adjacent side is going to be a root of 3. So you want to ask yourself, what value of tan of what angle x gives me root of 3 over 1? Now SOHCAHTOA comes, the tangent comes at the far end of SOHCAHTOA, which implies the opposite over the adjacent. So what angle is opposite to root of 3? Okay, and then adjacent to 1. What angle is opposite to root of 3? So it's actually pi over 3, right? It's opposite to root of 3, and yeah. So you can actually use a calculator to find that. Okay, so pi over 3, and then you can divide by 2 both sides. Your alpha is going to be pi over 6 after dividing by 2. Okay, so we found our theta, or our alpha, sorry, to be pi over 6. If you've forgotten the formula, it's actually tan 2 alpha is equal to your b over a minus c. If you use cosine 2 alpha, you actually swap a minus c over b. So now that you've got the angle, this is similar now to the previous question that we had, because we were given the angle and the equation, and whenever you do have the angle and the equation, the principle is very simple. Just remember the equations. You have to find the value of x in the new x coordinates and the y as well in the new x and y coordinates. So we said the formula is x is equal to x prime cosine alpha minus y prime sine of alpha, right? And then for y, what was it? So we said x prime sine alpha, the sign was opposite, y prime maintained, again it's the opposite there, cosine alpha. So what do you want to do now? Just substitute in the equations. So if I'm to substitute in the first one, so feel free to pause the video and just try to substitute and then see what you're going to find. After you find that, substitute back in that equation and see what you're going to end up with. Okay, so after we've paused the video, so x prime cosine of the angle pi over 6 minus y prime sine of pi over 6. Okay, now I've already made a comment. Pi over 6 is equal to 30 degrees. Okay, so you can, if you're thinking in degrees, you can think of that. So what's cosine of 30? That's root 3 over 2. So for the first part, we're going to have x prime multiplied by root 3 over 2 minus y prime sine pi over 6 times 30 is 1 over 2. So we're just going to multiply by 1 over 2. Okay. We'll do the same, we'll substitute in the one below. So x prime sine of that is again 1 over 2 plus y prime, that's cosine of the angle again is just root 3 over 2, which will give us x prime over 2 plus that's going to be y prime root of 3 over 2. Okay, so I can actually now say my x is equal to x prime root of 3 over 2 minus y prime over 2, and then my y is equal to x prime over 2 plus y prime root of 3 over 2 there. Okay, so after this point, now what do we do? Now that we found the x and we've expressed our x and the y in the form of the new coordinates, we can substitute in the equation. So first of all, we have 2x squared. So our x is this. So we're going to have x prime root of 3 over 2 minus y prime over 2, and then this is squared plus root 3 multiplied by xy. Our x is x prime root of 3 over 2 minus y prime over 2, and then our y is x prime over 2 plus y prime root 3 over 2, and then after that we have plus y squared. So plus y squared, our y is x prime over 2 plus y prime root 3 over 2 squared, and then minus a constant 10. This is equal to 0. So we've substituted now the x and the y values in that equation. So if you feel tired, feel free to pause the video because you need to get this. This is very simple. The steps are very basic. Just find the angle using a formula, express the x and the y in the new x, y prime coordinates, and then substitute in that equation. And all you need after that is just to simplify now. Okay? So just feel free to pause the video and just try to simplify this on your own. This is basic square. So you just multiply that brackets by itself twice, and then you do the same for this one, you do the same for this one, and then just simplify. Okay, so if you look at what we have here, so what can we do to make things faster and easier for ourselves? So we have x prime root of 3 over 2 minus y prime 2. So multiplying by itself. So the first part, if you multiply this by itself, we're going to have x prime squared. Root 3 by root 3 are just going to give us a 3, and then 2 multiplied by itself 2 is going to give us a 4, right? Okay, so that's when you multiply this by itself. So x prime multiplied by root 3 gives us that, and then this part multiplied by that part, what is it going to give us? So that's what we need to write now. Just move this a little bit. So if we multiply that by that, we're going to end up with x prime y prime root of 3 on top. On the bottom we're going to have 2 times 2, which is still going to be a 4, and then again on the next step as well, if multiplied by itself, if we multiply now, we've now moved to the part where we're now multiplying by that part with this part, so it will give us the same, it will be repetitive, which implies it's going to give us 2. Okay, and then now here on this part, if you multiply it by itself, it's going to be positive y prime squared over 4. Okay, this was in the bracket squared, now there is a 2 which is outside there. Okay, so we can proceed in the similar manner, root 3, and then try to simplify the other parts as well. Okay, this part multiply by that, again you get this part multiplied by that part. Okay, so I've given an example on how you do this on the first part. I believe you are able to simplify the other parts on your own. So 2 there, 1, 2 there, 2, 2 there, 2, 2 there, 2. So you end up with the coefficient is remaining there is 3 over 2, and then x prime squared. The 2 can divide, so that you only remain with root of 3, and then x prime, y prime. This part you've got y prime squared over 2. Okay, so y prime squared over 2, and then simplify this part. Okay, by the way, pause the video and try to simplify and then I've simplified on my paper to avoid just doing a lot of writing and talking. So everything else I'm ending up with 3 root of 3 over 4 x prime y minus root 3 over 4 xy y prime minus 3 over 4 y prime squared plus 1 over 4. Okay, 1 over 4 x prime squared plus root of 3 over 2 x prime y prime plus 3 over 4 y prime squared minus 10 is equal to 0. So remember, there were just three steps that we've done. Don't forget about what we're looking at right now. So this is just simplifying, trying to take it in a simpler form that we can. Okay, so now at this point the question is, are you able to identify the like terms? Are you able to identify the like terms? So first of all, if you try to observe the ones that are having x prime squared, there's this one. Whichever one is having x prime squared, so it's this one. So you're now going to add 3 over 2 plus 1 over 4. Okay, so common denominator there of course is a 4. So 2 into a 4, 2, that's 6 plus 1 right is mathematics okay there. So we've got 3 over 2 there attached to x prime. Which other one is attached? So there is the 1 over 4 which I've identified. Now I made an omission somewhere there. Yeah, there's an omission. Okay, so on my paper is this value that I omitted here. So y prime, after half y prime squared, there is 3 over 4 x prime squared. Sorry for that. Okay, so what we are going to end up adding, 3 over 2 plus 3 over 4 plus 1 over 4. Okay, so those are the ones that we are adding together. And so for and then 2 there, it's just like 2, 6, 4 there, it's 1, and times 3, it's just going to be a 3, and then 4 there, it's 1, so that's going to be 10 over 4, which if you divide by the 2, you're going to end up with 5 over 2 x prime squared. So we've dealt away with the ones that are attached to x prime squared. Okay, and then we can now look at the ones that are having let's look at the other like terms now. We've got the ones attached to x prime and y prime. Okay, and which is the other one is where is the other one? The other one is here. Okay, we've got this one there, and then there's also another one right there, and then there's another one right there. Okay, so let's try to write them down. So for the constants, we've got minus root of 3 plus 3 root 3 over 4 minus root 3 over 4, and then we've got plus root 3 over 2. Okay, common denominator 4. 1 into 4 is 4, so we're going to have negative 4 root 3, and then plus 3 root 3 minus root 3, and then 2 into 4 is 2, so we're going to have 2 root 3. Okay, so if you look at negative 4 plus 3 root 3, that's going to be a negative root 3, and then minus root 3 plus 2 root 3. So this is going to be a negative 2 root 3 plus 2 root 3, which is going to be a 0 over 4. Okay, so that part is going to be eliminated completely. This part, that part, that part, and that part, which was our goal. Okay, wanted to eliminate the xy part. So what remains now is the y prime squared over 2 minus 3 over 4 y prime squared, and then plus 3 over 4 y prime squared, which is our interest. Okay, common denominator 4. 2 into 4 is 2, so 2y prime squared minus 3 y prime squared plus 3. So with the negative 3 and the 3 will subtract. You remain with 2. 2 there it's 1, 2 there it's 2. So y prime squared over a 2 is equal to, this constant can be on the other side, it becomes a 10. Okay, so at this point, what do we have? I want to identify the conic section, so we want to have a 1 remain on the other side, so we can divide by a 10, 10, 10, 10. So for first part, 5 there it's 1, 5 there it's 2, so 2 times 2, 4, so we have x prime squared over 4 plus y prime squared over 20 is equal to 1. Now what kind of a conic section is this when you see an addition on the left? Okay, so that's an ellipse. If it's a subtraction, it's a hyperbola. Okay, so this is an ellipse. So another exercise, pause the video right away. I want you to find the foci, the center, the vertices of this ellipse. Okay. Okay, so the fact that the y I've given you the fact that we've got a bigger denominator on the y part, what does it imply? So it tells us the major axis is going to be along what? The y axis. Okay, I've given you a hint there. Okay, so the other goal, let's find now we know the ellipse is going to be in the form of x squared over a squared plus y squared over b squared is equal to 1. So we can find our a squared. So our a squared is equal to 4. Our a becomes plus or minus root of what? Root of 4 is 2. And then our b squared is equal to 20. So our b becomes plus or minus 20. Root of 20, that is. Okay. The other thing that is cardinal, b is just a representative. Okay. So there is a constant c, right? So c squared does relate to b squared minus a squared. Okay. In other terms, our b squared is addition of c squared and what? C squared and a squared. Okay, this is for a case for an ellipse. when it comes to the other case, it's actually c squared is equal to a squared minus b squared, or b squared minus c. B squared is equal to c squared minus a squared, but this is a different case. Okay, so now at this point I hope you've written down the coordinates. So our c squared becomes, our b squared is 4, our a squared is, what do I said? My b squared is 20, our a squared is 4. So our c squared becomes 16. So our c, therefore, it's plus or minus root of 16, which is a 4. Okay. Now, I always give you some hints that can help you deal with certain things like this. When you look at an ellipse, where is the foci? The foci lies within the ellipse itself. The vertices are outwards, so the bigger value will go for the vertices. Okay, so which one is bigger between C and A? C is bigger, so this is going to represent the vertices, right? Okay, is it true? Is it true? Are you doubting? Are we on the same page? Okay, so the fact that this is actually along the y-axis is one point that you should actually keep in mind. Okay, very, very important. So our C is there. What's the value of B? The value of B is also a value that you need to be mindful. Root of 20. What do you expect to be the value of root of 20? Approximately what? 4 is 16, so it's something like 4 point something for B. So which actually makes it to be a bigger value, right? So if you try to simplify it in terms of a SAD, that would be plus or minus. Root of 20 can be a product of 4 and 5. So you end up with plus or minus 2 root of 5, which is actually a bigger value. So that one is going to take now the longer one. Okay, it's longer than the C because this is approximately greater than 4. Okay, so for an ellipse, you've got 4 vertices, so it's important that you determine which one is bigger. So the biggest value is for B in this case. Remember, I did mention to say that the fact that we've got a greater denominator for y, it implies this is going to be in this form. So the biggest value we have is the root of 20, or 2 root of 5. So that's going to present the vertices, 2 root of 5, and then 2 root of 5 as well. So that's the y coordinate. Okay, assuming this is along the x or y plane. Okay, of course in the new coordinate system. And then of course if you look at the other value of the vertices, which of course the smallest value is going to be for the foci. So therefore, no, not the smallest value is not going to be for the foci. The smallest value is going to be the vertices along the x-axis. Okay, so which is represented by our A, right? So this part is going to represent the vertices, so -2 and 2, and then the foci, which is going to be inside part, the y values as well are going to be presented by the 4, so 4 and -4. So in summary, when you're trying to deal with an ellipse, if you've got your A, B and C, the key part is to determine which one is the biggest value that represent the major axis. In a case where, for example, this one is actually it's along the y-axis, the bigger value was the root of 20, so which has ended up being the major axis, which is along the y-axis. So therefore the coordinate for our vertices are plus or minus, which is actually the y coordinates, so plus or minus root of 20 or 2 root of 5. These are 2, you can split them, one with a positive, one with a negative, and then the other set is plus or minus 2 of 0, which you can also split, giving you 4 vertices. And then for the foci, which was our f value, we've got 0, 4 and 0, -4 because it's along the y-axis. Okay, so all these are given in the new set of what? In the new set of the xy plane that was rotated. Okay, the new xy prime coordinates. So there may be a question where they want you to go as far as proceeding and determining the vertices and the foci in terms of the x and the y itself. So because remember, what we've used here is we've used the x prime and the y prime, right? So you can go as far as now using the original coordinates. Okay, and how do you do that? So this is now where you go back to the form of the equation again, where we said our x is equal to x prime cosine alpha minus y prime sine alpha. Okay, so if you look at, I can give you one example. If you look at the foci, our foci of 0, 4, for us to find the one for the x, so for us to find the x value there, we have to use this formula. Okay, so our foci in the x y original is going to be, our x prime is 0. Remember, we were dealing with x y prime, so this is x prime y prime. So if we're taking it back to the original form, we use that equation. So we're going to have the x prime, which is 0, of course 0 multiplied by whatever we're going to have, the cosine of the angle that we found. What was the angle? If you took note of it, the angle was pi over 6, which is a 30. So that's just a 0, and then this part minus, okay, minus what? Minus y prime, which is a 4, and then sine alpha, sine 30 is what? Half. Okay, that's for x coordinate, comma y. Now for y, how do you go about it? So you also have to write down the formula again for the y part. So y is equal to x prime sine alpha plus y prime cosine alpha. So to find the y coordinate, we equally have to substitute in that equation. Okay, and how do we do that? So what is our x prime? X in this case again still remains a 0, and then sine pi over 6, which is still half, will still be a 0. Now that part plus y prime, which is a 4, and then cosine the angle, cosine that, so cosine 30 is what? Root 3 over 2. So that's how you're going to find the first coordinate of the foci, 0, 4. Okay, the same principle applies to the other coordinate. So this part is going to be negative 2, comma 2 there, 2, that's the 1, so it will be root 3. So that's going to be the first coordinate of the foci in the new set of what? In the new set of coordinates. Okay, negative 2, comma root of 3. So you apply the same to the vertices as well using these formulas. Okay, these questions are rare, but it's possible they can ask you those questions. So if you are very familiar with those equations, it's very simple for you to handle this. Okay, so now your exercise is to pause the video and go as far as converting all the vertices to that form. Okay, so the values that you should end up with for the other foci value, 0, -4, if you substitute in that formula, the coordinate is going to become what? 2, -2 root 3. And then for the vertices, If you convert the first one, which is 0 comma 2 root 5, positive part is going to be negative root of 5 comma root of 15. Then you get the negative 1, 0 comma negative 2 root of 5. It's going to be root of 5 comma negative root of 15. Okay, so basically this is what you basically do when it comes to rotation. The basic idea is to do away with a value of x and y. Okay, so now I'm going to attach a PDF with practice questions about translation and rotation, and do well to practice them before we proceed now to the simpler concept of a discriminant test, which can also help us deal with x, and which can help us identify the conic section without actually going as far as dealing with x and the y. Okay, so thank you very much for watching. I hope you've learned one or two things.